All right, guys, so this is our first Flip the Classroom lesson of Chapter 9, and in this lesson we're going to talk about basic combinatorics. Now, the root of combinatorics is combination. And what we're going to be looking at in this lesson is the number of ways a series of stages in a procedure can combine to produce an outcome, right? So in looking to find the number of ways we can produce outcomes, we're going to be working largely with the multiplication principle of counting. And in the multiplication principle of counting, we say that if we have a procedure, P, that has a sequence of stages, S1, S2, all the way out to Sn stages, right? And if S1 can occur in R1 ways, S2 can occur in R2 ways, all the way down to Sn occurring in Rn ways, then the number of ways that the process P can occur is the product of the number of ways that each stage can happen. So R1 times R2 all the way out to times Rn. So let's look at an example of this. I think it'll make it a little bit easier to see. Our first example is asking us how many different license plates begin with 3 digits followed by 3 letters. So right here we've got a procedure of creating license plates where we're taking 3 digits and following them by 3 letters. Right here we would consider each stage to be the selection of a digit or a letter. Now with the digits, we can say we're selecting digits from 0 to 9, so that would be 10 digits we'll be selecting from, right? And for our letters, we'd say we're selecting from the alphabet, which has 26 letters. So right here, let's set this up. We are going to have stage 1 of our process being selecting the first digit. Stage 2 would be selecting the second digit. Stage 3 would be selecting the third digit, right? And then we're moving on to our letters. So stage 4 would be selecting the first letter. Stage 5 would be selecting the second letter. And finally, stage 6 is selecting that third and final letter. So what we want to do is go through and figure out how many ways each stage can happen. So how many ways can we choose the first digit? Well, we've got 10 digits to choose from, so we would say there are 10 possible ways we can choose the first digit. Similarly, we are choosing a digit again, so we can say there are 10 ways that we can select that second digit, 10 ways to select that third digit, right? Now we're moving on to our letters. So right here what we're going to say is we have 26 ways to select that first letter, 26 ways to select the second letter, and finally 26 ways to select the third letter, right? So we can repeat letters and digits in this case, and right here what we would say is that the total possible number of outcomes, total possible number of license plates we can get would be the product of all the ways that each stage can happen. So right here, when we multiply all this out, we get right here 17,576,000 different possible license plates that we could get by choosing license plates with 3 digits followed by 3 letters. So a variation on the multiplication principle of counting, or we might say another way we can apply the multiplication principle of counting is in the arranging of items in a particular order. So right here, we're looking at how many ways we can arrange the letters A, B, C, and D in a particular order. And a good way for us to visualize this is with a tree diagram, right? Where basically right here we've got the first letter we can select as A, B, C, or D, right? If we select A first, right, we can select B, C, or D next, right? And if we select C next, then right here we've got 2 possibilities for the third letter, right, B or D. And then if we choose D as our third letter, then there's only 1 possibility of B for that last letter, right? So right here, what we can see is that really what we have is a 4-stage process for arranging these letters, right? The first stage, stage 1, is selecting our first letter, right? The second stage, stage 2, would be selecting the second letter, right? The third stage is going to be selecting the third letter, and finally our fourth stage, we're running out of room a little bit right here, is selecting that fourth and final letter. If we think about stage 1, you can see that there are 4 ways for stage 1 to happen. We've got 4 letters to choose from first. Now, after we've selected that first letter, in stage 2, we only have 3 ways for our second stage to happen. Then right here, in stage 3, we've only got 2 letters to choose from after we choose our first 2 letters. And finally, in stage 4, we really only have 1 letter for that last stage. And we're seeing the multiplication here with our tree diagram, right? So right here, if we set this up with a multiplication principle of counting, we would say here that our process would be 4 ways for the first letter to be selected, times 3 ways for the second letter to be selected, times 2 ways for the third letter to be selected, times 1 way for that last letter to be selected, which gives us 24 possible different ways of arranging those 4 letters. And we're seeing that right here. Now, all of these different possible arrangements we call permutations. Now, permutation is the arrangement of items in a particular order, right? The process by which we get all of our possible permutations is what we call a factorial, right? And basically, a factorial is going to be a multiplication of integers from the number of items we have, 4, back to 1. So right here, we would say that this would be 4 factorial, and 4 factorial is going to be 4 times 3 times 2 times 1, right? Where we're basically reducing by an integer each time, multiplying all the way back to 1, right? We've got this laid out right here. We'd say that factorials is the mathematical process of finding the number of possible permutations, right, for a given list of n items. So it's the number of ways that we're going to be able to arrange n items in an order, right? And right here, the number of letters we have is 4. So right here, we would say that if we wanted to talk about arranging those 4 letters, that would be 4 factorial. And right here, we write it with a little exclamation point at the end. And right here, we have 4 times 3 times 2 times 1, giving us 24 possible arrangements. Now, this tree diagram is a great way for us to sort of see this multiplication, right? We've got 4, and then for each of our 4, we've got 3 for the next, right? So 4 times 3 is giving us our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ways of selecting those first 2 letters. Then right here, we're multiplying each of our 3 by 2, right? Literally multiplying them, they become 2, right? And right here we've got our 24 ways of selecting those first 3 letters, and we really don't have any way of selecting that last letter or any choice in that last letter. That last letter's got to be whatever we didn't choose first, second, or third. Now we could apply this same method of visualization of the multiplication principle of counting for our license plates, but it's going to be a lot more messy. Right here we would start out with basically 10 digits, right? And then from each of those 10 digits, we would have 10 branches, right, from that digit, right? And that would happen twice. And then we would start on our letters, and we would have 26 branches, right, off of the first, off of all the possible ways to get the 3 digits, and we would do that 3 times. So obviously, that kind of tree diagram would be really crazy to look at, and it's much more easy to sort of think about it with the multiplication principle of counting. Okay, so we're going to let you guys try some problems on this next page. Right here we have how many different license plates begin with 3 digits followed by 3 letters if digits can be repeated but letters cannot. So right here, I want you guys to give that one a shot. Also look at how many different schedules are possible for a 5-period school day with math class, history class, English class, and science class, or science class and a language class, right? So we've got 5 periods and 5 classes to fill those periods, and we want to talk about all the different arrangements we can have for our schedules. And next, right here, how many different schedules are possible if you will play one of 3 sports at the end of the school day, right? So why don't you guys go ahead and give this a shot. Obviously, this last problem sort of references back to your 5-period school day. Why don't you give these a shot, and we'll come back and look at these in a second. All right, guys, so here we are. With our first problem, we have how many different license plates begin with 3 digits followed by 3 letters if digits can be repeated but letters cannot. So right here, if we're saying digits can be repeated, then we've got 10 possibilities for the first digit, 10 possibilities for the second digit, and 10 possibilities for the third digit, right? But if letters cannot be repeated, then right here we have 26 possibilities for the first letter, and after we've selected that letter, right, we can't repeat it, so we've only got 25 possibilities for the second letter, and then after those 2 letters have been selected, we only have 24 possibilities for that last letter. And if we multiply all this out, we're going to get 15,600,000 for the total possible number of license plates there. Right here, when we're looking at our school day problem, how many different schedules are possible for a 5-period school day with math class, history class, English class, science class, and a language class. Right here, we've got, basically, we're talking about arranging 5 classes, right? So right here, we would say that would be 5 factorial, right? 5 possibilities for the first class, 4 possibilities for the second class, 3 possibilities for the third class, 2 possibilities for the fourth class, and only 1 possibility for that last class. And when we multiply all this out, we get 120 possible different school days, right? Now, right here, if we sort of also add in 3 sports in the afternoon, right? Now we can kind of think about this as the multiplication principle of counting. We've got number of ways the first stage can happen, the school day, times number of ways that the second stage can happen, right? And right here, what we would say is that would be 5 factorial times 3. So right here, this would be 120 times 3, which gives us 360 possible school days plus 1 of 3 sports. All right, so right here, we will stop this video and move on and talk about more combinatorics in the next video.